Let's give you guys some more practice. So determine if this series will converge or if it will diverge. So press pause and have a go. Okay, so to do this, try to develop a bit of a gut instinct on what's going on. So if you look at this, 2 to the power of, let's say 2 to the power of x, compare that with x squared. So you see x squared looks like this, 2 to the power of x looks like this. As x or n gets bigger and bigger, you can see that 2 to the power of x will be a lot bigger than x squared. So if you look at 1 over, x squared, so the blue line is 1 over x squared, the red line is 1 over 2 to the power of x. You see, as x gets bigger and bigger, this will always be bigger than this. So this, hang on, 1 over x squared here. This will always be bigger than this. So if you know that this thing's going to converge, you know that well, don't forget you can cut out anywhere. Let's cut out at 6. You can cut out at 6. So this thing here, you've got this thing here, 1 over, let's say, n squared. You do have the right to cut out anywhere you want. We are only interested in the tail end of things. So you do have the right to cut out anywhere here, or you can cut out here, because around here, x squared is less than 1 over x squared is less than 1 over 2x. But you can keep things simple by just cutting up anywhere you want and just analyze the tail end of things. So the point here is that you know that this thing will always be bigger or will be bigger or equal to this thing here. So if this, you know that this thing is going to converge, so you should have a gut instinct that this thing here is going to converge as well. So let's just do it anyway. Let's pretend we didn't know that. So we are trying to determine whether or not this thing will converge or if it will diverge. So first thing to do, check that the limit of this thing heads towards 0. So as well, as n increase from 1 to infinity, this thing here does head towards 0, because this thing here is just going to get bigger and bigger and bigger. So this is okay. So now that now that we've done this, we need to make use of that theorem. The theorem that says if this thing here diverge, then this will also diverge. If this will converge, this will also converge. We need to make use of that theorem. But in order for us to make use of that theorem, we need to check these three. So let's check that it's continuous. Well, this thing here, well, nothing breaks down. Well, you asking whether or not this thing will be continuous from in the domain of 0 to infinity, it's really you asking when will this thing break down. This thing here will break down when this equals 0. When will this equal 0? It will never equal 0 in the domain from 1 from 0 to infinity, from 0 over to infinity. It will never be 0. This thing here will be continuous. Is it always positive? Yes, it will always be positive. Is it decreasing? Yes, it will always be decreasing. Because all these three have been satisfied, we can now make use of that theorem. The theorem that says that if this thing diverges, this will diverge. This thing converge, this thing will converge. We can now make use of that theorem because all these have been satisfied. So now it really boils down to us determining whether or not this thing will converge or if it will diverge. So we've got to use improper integrals here. So hang on. So we now need to integrate this. We now need to integrate this. But let's visualize this. Hang on, bear with me. So let's visualize this as 2 to the power minus x here. So this thing here is 2 to the power minus x. So now we need to integrate this. So let me take you back a few steps. A while back, I will continue in the next video. Okay.